Hello everyone, welcome back. In this video we are going to focus on plotting for in a statistical concept. So we're going to start with histograms. To get started we need the same standard imports that we always use. So import numpy as np from matplotlib, import pyplot as plt. All right, so now for a histogram, we're going to get 1,000 normal random variables. So we're going to let x be np.random.rand n, rand normal, for normal random variables. And to get a histogram, what we do is we do the same figax procedure that we always do. Figax equals plt.subplots 1. And then we do h is equal to x.hist of x. And one thing we notice is that it automatically chooses the bin width for us, and it usually is pretty smart. By the way, if you don't know what a normal random variable is, this is the probability distribution that follows the so-called bell curve, which you can kind of see here. Or if you really aren't familiar with normal random variables, just don't worry about it. It's something that makes the data look like this. All right. So we've already seen that we can, so next we will see that we can specify how many bins we want to use. So we do x.hist x bins equal 40. And then we take a look at our figure. And now we see we made another version on the same plot with 40 bins rather than the default probably had 1, 2, 3, 4, 5, maybe about 10. And since there's more bins, there are less items in each bin. So a common situation like this is we've got these two things on top of each other and they're blocking each other out. So in the next example, we're going to have 3 different data sets and we're going to plot them with a little bit of transparency so that way they don't completely block our view of each other. All right. So x1 is going to be random normal with mean 0, variance 0.8, and we're going to get 1,000 of those. x2 is also going to be random normals. But now we're going to make the mean equal to -2 and the variance equal to 1. And we're going to take 1,000 of those. And then x3 is also going to be random normals. And now we're going to make the mean be 3 and the variance be 2 and take 1,000 of those. And so we're going to plot all of these with the same keywords. And so here's a good opportunity to reuse quarks so we don't have to type things 3 times. So quarks, we're going to set it being equal to a dictionary. Bins equals 40. Alpha equals 0.3. And then we do plt.hist x1 * quarks. plt.hist x2 * quarks. And then plt.hist x3 * quarks. And it gives me an error because I misspelled quarks. And now in order to look at the figure, we add in a semicolon. Here we didn't use the figax display. So if you're just using plain vanilla plot, you can make the plot appear by adding a semicolon to end the line. Another trick to keep in your back sleeve. So here we see that we've got 3 partially overlapping probability distributions. They all roughly have the bell shape, but they have different widths and they have different centers. Up next is box plots. This is another cool way to visualize your data. Sometimes these are also called a box and whiskers plot. So for this one, we're just going to need one subplot. And then all we do is we say box is equal to x.boxplot. And we get 3 box plots, one for each of the probability distributions. So this is just another way of encoding the same information as the histogram. So the last topic for this video is how to make 2D histograms for plotting two-dimensional data. So for this, we're going to play around with the multivariate normal distribution. And if you're not familiar with the multivariate normal distribution, don't worry, just bear with me. You'll still be able to see what's going on in a couple of slides. So we're going to say mean is equal to 0, 0. Covariance is going to be equal to a list of lists with 1, 1, 1, 2. And then here's the part which really don't worry if you don't understand it. We're going to say x is equal to np.random.multivariate normal with mean, covariance, and then we're going to have 1,000 of them, and we're going to take the transpose for technical reasons. And now we can do a PLT scatter plot of x and y. And what we see is this doesn't really look that great. The data is all on top of each other, and we might want to try to interpret this a little bit better. So instead of doing the scatter plot, we're going to do what's called a 2D histogram. So here what we're going to do is we are going to say fig x is equal to plt.subplots 1. H is equal to x. It's a 2D histogram, so you type hist2D. X, Y, we're going to set the number of bins to be equal to 50. And now this is starting to get a little bit better. But I don't really like this color scheme. I actually like a different color scheme. I like to call this color scheme CMAP equal to blues. And let's also actually give it a color bar. We're going to say plt.colorbar. And for arcane technical reasons, we type H3, so it's the third member of H, rather than just H itself, and we say label equals counts in bin. And now we can see that our multivariate normal distribution, it kind of has like an ellipsoidal type shape, and it's mostly concentrated right towards the middle, right here. Now, the one last thing before I let you guys go is there's nothing wrong with doing it this way, but sometimes it actually looks better to have hexagonal grids rather than square grids. So here we're going to do subplots 1. H is equal to x.hexbin. This is for a hexagonal bins. You'll see in a second, this is going to look really pretty. We say grid size is equal to 50 rather than the number of bins, and we again set the color map equal to blues. And then we do plt.colorbar. Now, when you're doing hex bins, you actually can just type H, and now we say label equals counts in bin. And now we get this really pretty looking thing where the hexagons make it look a little bit rounder and less blocky. And we get this beautiful histogram. So that's it for this video. I'll see you guys again next time.